Okay, good afternoon, everyone, Nana. Hmm, right. Yesterday, I think we discussed up to static friction. Am I right? Yes, and explained what is the biggest drawback in static friction. Yes. Now, once again, try to recollect for what purpose we use FMS is equals to mu s into n. Is it used to find out the static friction or else to check whether the body is at rest or in motion? This is used for checking purpose or to find out the static friction. Yeah, to check whether it is at rest, checking purpose, right? It is whether it is at rest or in motion. Very good, very good. So static friction is always equals to applied force. Okay, good. This is for checking. Okay, FMS says whether the body is at rest or in motion. How it says are simple. If F applied force is less than or equal to FMS, then you conclude the body is at rest or in motion. Is very good, very good. Who is this? Ishan. Wow, Ishan. Nice. Is at rest. Very good, very good. If applied force is greater than FMS, then the body is in motion. Very good. So this FMS only used to check the state, whether it is at rest or in motion. Okay, good. Now first you better finish the static friction, sir. Then we will go to the case, second case, F is greater than FMS. Okay, sure. Come to the models related to static friction. Already I said few examples there on inclined plane and on the horizontal plane. If the force applied is less than or equal to FMS, what is the static friction we found in the previous examples? Yesterday and in Saturday's class. Okay, I think you understood. Okay, come to the other model here. If I take one example here, what is that example, sir? Suppose he said a body of mass, say 2 kg. 2 kg means 2 into g, 10, 20. Mg is 10. Okay, a 2 kg is placed on a horizontal surface and a force of hmm, okay, 20 newtons is applied on the body. Okay, better I take a bit less value. I take here 10 newtons. Right. Mm, 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 mm. Mu, yes, coefficient of static friction is 0.8. Okay, find the contact force. Okay, it is important for both board exams, means subjective exams, board exams, and for objective exams. For both, this model is important. Okay, right. Come to here. How to solve this type of model? First, I think you know how to check. First, check whether the body is at rest or in motion. Already I said how to check. First, we have to write in the solution what is the applied force. Wow. Shrestha, this time very fast. Lakshmi Gayatri, you checked properly, Nana? Mm, mm, mm. Ishan, correct. Ishan in full josh. Oh, in full form. Lakshmi Satvika, what is this, Nana? Your answer? Satvika. Okay, okay. I will check Satvika. Lakshmi Gayatri, now you are right. Good. Right, Nana. Right, right, right. Here applied force is actually 10 newtons. Okay. Oh, Akhil Golapudi, what is this? You checked? Tanisha, yeah. Today, I think she got the form. Very good. Keep it up, Nana, Tanisha. Good. Now Lakshmi Satvika is correct. Very good, Tanisha. You said the answer also. And then, yeah, good, good. Now correct, Akhil. Applied force 10, whereas FMS is equals to, actually we have to take mu s into n, placed on horizontal surface. On horizontal surface, n is equals to mg. So if you check here FMS value, mu s given as 0.8, m given as 2, g as 10, then you will get this is 8 to the 16 newtons. Yes. What Yastra Manikanta? 16 and this is 10. So we can write here F is less than FMS, surely. Okay. F is less than or equal to FMS, the body is at rest. That implies the body is at rest. If the body is at rest, friction is static friction. Static friction is always equals to applied force. Applied force is 10. Therefore, Fs is equals to 10 newtons. This is correct. Okay. But he asked not the static friction, find the contact force. If I leave the question for a while to you, what do you say the answer for the contact force? Okay. Is it contact force for Lakshmi Gayatri? What you put the answer there? Is it the contact force? Say yes or no, simple. Okay, that is your answer, right? Others? Lakshmi Satvik. Okay, that is your answer. Okay, right. Next. Only two Lakshmis are responded. Okay, actually we have Astalakshmi. Where are the remaining Lakshmis? Okay. Others? Ishan boy, Amog bhai, Deepali Bibi. Others, Tanisha Begum. Your answer is okay this time. Okay. Where is Babu Bangaram? Mr. iPad? Sister. Okay, right. Uh, I know, Mani Babu. Babu Bangaram. Are Amog, where are you, Ra? Here or in YouTube? Day by day, I'm finding out your response very less. Here only. Then where is your response, Ra? Thinking. I think that you are thinking. Hmm. Even for this also, there is no response. Okay, okay, okay. I think not followed properly in another question. Yeah, I understood. Thinking. Right. But think properly. Why? Guys? Because little bit logical question. Sure. I don't think it's so. Here, contact force means what you are thinking. One is, sir, friction acts tangentially in contact. That's why whatever I found the friction, that may be the contact force, sir. Okay. Yeah, friction is a contact force, but it is not the answer. Okay. I accept what you said. Sir, between the two surfaces in contact, tangentially friction acts. So it is a contact to both the surfaces. So friction is a contact force. If friction is contact force, why not the answer 10, sir? Why? Because friction I got 10. What I am saying, not only the friction, one more is there who is the other, he is also the contact force. Identify who is the other, which is a contact force. Yes, now Ishan, right? Perfect. Very good. Yes. Lakshmi Gayatri. Yes. Normal reaction is also a contact force. Okay. Yes. So not only the friction, normal reaction is also there when two bodies come into contact. Okay. So two contact forces we are finding out. So on smooth surface, we say, sir, on smooth surface, friction is not there, sir. Friction zero. That implies contact force that time. In laws of motion chapter, we said contact force is equals to only the normal reaction. Normal reaction on the flat surface is equals to downwards mg. That mg is equals to 2 into 10. That you will get 20 newtons. Yeah, this is 20. But this is on smooth surface. But on rough surface, I say, whereas on the rough surface, you are finding out two contact forces. One is tangential friction, other is normal reaction perpendicular to the surface, or the contact forces. Two forces are there means I have to find out total contact force. Resultant of them I have to find out now. Resultant, I should not add them directly. Why? Because force is a vector. Vectorial sum I have to take. Since they are perpendicular to each other, shall I use the Pythagoras principle, Nana? Shall I use? Yes. So root of, I have to say, one is n square, other is f square. This is the formula to be used to find out the contact force on the rough surface. I think now you will get the answer. And this is the contact force on horizontal surface. Sorry, a smooth surface. Okay, better I include this part also. Okay, this is on smooth surface. Here, this is on the rough surface. Contact force is equals to, Array, Satvika, what is this ra? Root of f square plus n square ra? Is it 20? Ah, Lakshmi Gayatri, yes. Yes, yes. That is equals to, that implies C is equals to root of n square is 20 square. Yeah, right, right. And 656, Anana. Akhil, how you got 656? Friction is 10 only, na? Normal reaction is 20. I think I'm getting 400 plus 100, root of 500, Nana. Ah, yeah, 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 yeah. That is 10 root 5, na? Correct. This is 10 root 5 newtons. Now you understood how to find the contact force, Nana? Okay. I explained on both the surfaces, Nana. On smooth, how to find the contact force. Yeah, on rough, how to find the contact force. Very good, very good. So don't go into a misconception that contact force is only the friction. Friction and normal reaction. Okay. Resultant we have to find out. It is the contact force. Okay. This is one example. Very good. And then come to second example. Example 2. Here in this example, what I'm saying, in the above example, find the angle of friction. Okay. I think if I ask, then immediately you won't get any idea. I feel. No, 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 no. Lakshmi Gayatri, it is not zero. First of all, you have to understand what is angle of friction. Who is the angle of friction? Okay. So first, I think you won't get any idea for this question if I ask like this. But the same explanation if I continue here like this. Nana, on rough surface, this is one contact force. Okay. This one, you know who is this contact force. And another contact force on rough surface, of course, even in smooth also, that is normal reaction. Nana. These are the two contact forces. And here resultant contact force using the Pythagoras principle, you already calculated, Nana, here in this pink color box. A resultant using the parallelogram law of vectors. No, 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 no. Ah, yeah. No need to say limiting friction, Nana. That one at the time of rest, you can call it. Okay. Yeah. So yes. So here, this is the resultant force of F and N. We called and represent contact it as contact force represented with the letter C. It is the resultant force. That resultant force with the normal reaction makes how much angle? This is theta. Okay. That angle here shall I get like tan? Yeah, good. Tan theta is equals to, I have to say, F opposite side by adjacent side N. Tan inverse F by N. Yeah, that implies theta is equals to tan inverse F by N. Okay. Tan inverse F by N means tan inverse F. How much, Nanu? F 10, N 20. Right. Tan inverse 10 by 20. That implies theta is equals to tan inverse 1 by 2, 0.5. Okay, good. But keep in mind what Akhil Golapudi posted. Okay, this angle, this angle, what we measured is not the angle of friction. Keep in mind, it is not the angle of friction. Okay, when we call this angle as angle of friction, he asked angle of friction, sir. Okay, when here exactly what Akhil Golapudi posted, Akhil only, na? Yes, Akhil only. Akhil Golapudi posted here, angle made by the resultant of normal reaction and limiting friction. Exactly. Okay, no problem, no problem. Okay, right. Here it is the not the angle of friction. Why? Because at this time the body is at rest or in a state of motion, about to slide, Nana. Maximum static frictional force is 16, but applied force is not 16. Means static friction I am not getting 16. This is 10 only. That's why it is not in a state of limit. Means about to slide. Okay, but if the applied force is 16 newtons, then what do you say? In the previous example only, Nana, if the applied force is not 10, if it is suppose 16, then what do you say? F is equals to FMS or F is less than FMS? Yes, you are right, Agmuk. Not in motion. Shrestha, F is equals to FMS. Motion means it should be greater, Gadanana. It is still at rest, but about to slide. Okay, ready to slide. Yes. So when applied force is equals to 16, that is F is equals to FMS. Okay. Then we write the body is about to slide. This condition in previous class we named it as limiting. Angle made with the normal only, Nana. With the normal means with the vertical only, correct only. Lakshmi Gayatri, correct only. Angle is made with the vertical. With the vertical means normal. With the normal. Okay, is about to slide. That is limiting condition. Okay, that time we write, okay, that implies tan theta is equals to, I have to write instead of F ms by n. Okay, that implies theta tan theta equals to Fms is 16 by n. N is how much, master? N 20 divided by 20. I think Mr. Amog, we are not getting 45 degrees. Oh, that is your doubt now. Yes. Simple, Lakshmi Gayatri. Whether the surface is rough or smooth, who is the existing contact force? Normal reaction. That's it. So he is the reference for us. That's why we are measuring the angle with the normal reaction. Is it clear now? 37, Anna. Yeah. No problem, Nana Deepali. Yes, Lakshmi Gayatri told. Yes, very good, very good. That implies tan theta equals to 16 by 3. Okay. That is 4 by 5. 4 by 5, I think, is not 37. Mr. Amok, again, you did mistake here. 3 by 4 is 37. Not even 53. 4 by 3 is 53. If tan theta is 4 by 3, then that is 53. If tan theta is equal to 3 by 4, then theta is equals to 37. It is neither 53 nor 37. Keep in mind. Just tan inverse 4 by 5. That's it. Very good. That implies theta is equals to tan inverse 0.8. That is 4 by 5. 4 by 5 is 0.8. Yeah, correct. That's it. Okay. Then you may ask, sir, why should I calculate this angle of friction? This is called as, here theta is called the angle of friction. Okay. Now is it clear, Nana? When should we call that as angle of friction? When it is at rest or when it is about to slide? When to say that the angle is called angle of friction? When it is at about to slide. Right, good. About to start its motion. Very good. At that time only, whatever the angle we found here is the angle of friction. Means tan inverse 0.5 is not the angle of friction. Tan inverse 0.8 is the angle of friction. Okay. You can ask, sir, actually, why should I calculate this angle of friction? Unnecessary data na here. Okay. No, Nana. In one case, the theta is giving the direction of resultant contact force, like in parallelogram law of vectors. Okay. So angle of friction gives the direction of contact force when the body is about to slide. I say not only, but also check there, tan theta is equals to, we got Fms by n, if theta is angle of friction. Okay. So at that time, this theta is called as angle of friction, Fms by n. To find out Fms, check back what is the formula? Mu s into n. So if I substitute in place of FMS here, that implies tan theta means angle of friction is equals to mu s into n by n. How much I'm getting here? Tan theta is equals to mu s. Is it right or not? Yes, yes. So in a problem, suppose if they give the angle of friction, it is very easy to find out mu s value. That's what I'm saying. Understood? That's why keep it as a shortcut in mind. Oh, angle of friction is given means mu s value is given. Okay. Sir, how to apply this one in numericals, sir? How they give this concept in exam? Okay, simple. Take one example. A body is at rest or a body is placed. Better I write the mass here. A body of mass 1 kg is placed, okay, on horizontal rough surface. On a horizontal rough surface. Okay. The angle of friction is say some 30 37 degrees. Angle of friction is 37 degrees. Okay. The applied force on the body is say some 5 newtons. Find the state of the body. Amog, wow. Good. Amog already responded, but we don't know whether it is correct or wrong. Others, what will be your answer? State means I am asking not Telangana and Andhra. State means whether it is at rest or in motion. Yeah, you are correct. Then, oh, Manibabu also, I think, gave the same answer. Shrestha, same answer. Lakshmi Satvika, same answer. So might be that one correct. All they put the same answer. Oh, this time Srivalli responded after a long time. Srivalli, good afternoon. Varun Babu, yeah, after a long time again. Yashashwini, yes. First time I'm seeing. Good. Right. Yeah, Deepali. Oh, right, correct. Good. I think all of you, what you posted, I think correct. Sharma, Dornala. Okay, right. Okay, we will check. Angle of friction theta is equals to given as 37 degrees for us. Theta is 37 means that is used to find out mu s from the previous concept. Oh, FMS is 7.5. Okay, I will check. That implies FMS. That implies first mu s is equals to tan theta. Tan 37 is 3/4. Okay, So FMS is equals to mu s into n. That is 3 by 4 into n is mg. What is the mass? 1 kg. 1 kg means 10. This is 0.75 into mg is 10. Yeah, exactly, Lakshmi Gayatri. That is 7.5. Accepted. Okay. Yes, yes, Akhil, correct only. Yes. Ishan also correct. 7.5. But I think Amog posted it is 15. 12 he posted. I don't know where you did the mistake, Mr. Amok. Yeah, this is 7.5. Whereas applied force is equals to F is equals to 5 newtons. Applied force is less than FMS. That implies, okay, maybe, right. Okay, no problem. F is less than FMS means the static friction is equals to applied force, that is equals to 5 newtons. That implies state it is less than FMS. The body is at rest. Okay. Now, are you able to solve these type of static friction problems, Nana? Now you got some confidence how to solve the questions related to static friction? Yes, yes, very good, very good. So static friction, I think all of you understood. Why? Because previous question, all of you put correct. Okay. What don't know, Ra? Babu Bangaram. Right. Except Babu Bangaram, all they should. That comes on practice. It is a common thing. First of all, what I asked, will you solve all the questions or not? That is not my question. You got the confidence or not? That's what I asked. Yeah, right. Because no man is perfect. Of course, no woman also. No man or woman, boy or girl, okay, anyone is not perfect in the world. So everything will come under practice only. By doing lot of practice, we will be perfect. Correct, Mr. Amok. Yes, yes, yes. First of all, we require confidence. Yes, I can. Okay. Then after practicing, that is a different story, whether you can or not. That is depending upon your practice. Yes, good. Right. So majority of the people, they said, yes, sir, we can. Right. Then I am coming to if the concept here, if the applied force is greater than FMS, no condition of equal to. Equal to also comes under rest. So F is greater than FMS. Then the body slides, coming into other type of friction. Static friction concept over. Okay. At the time of sliding, the friction between the surfaces, keep in mind, not like static friction, remains constant. It does not change. Thank God there are no conditions. Remains constant means might be there only one formula. Oh, compared to static friction, what the sir is going to say, this might be easy for us. Okay, remains constant. Okay, between the surfaces is called. This is either you can call it as sliding friction, or in majority of the books, they name it as kinetic friction. Okay, any name you can use, both are correct. Kinetic friction or sliding friction. This is represent as usual. Since it starts with a K, this is Fk, kinetic friction. Okay, since it remains constant, obviously Fk also depends upon the normal reaction, like the maximum value of static friction. So here also we write Fk is directly proportional to N. That I will explain it later, Nana. That will come on inclined plane. Okay, there I will explain. Okay, Fk equals to some constant into N. That constant here, there we wrote mu S. Here we are writing it as mu K. So Fk is equals to mu K into N. Okay. After coming into motion, the disadvantage is already the surface after coming into motion, even on the highways also we observe when many buses or lorries or heavy trucks or cars or bikes move on the road, then because of the friction between the tires and road, that one who what they laid previously, okay, either cement road or tar road, okay, whatever it may be, okay, that will come out of the surface and you can find few ditches on the ground like patches. Okay, that means when vehicle once starts coming into motion, the friction between the two surfaces means the roughness gradually decreases. That's why here once the surface comes into motion, what he says, this Fk what you are going to calculate surely less than Fms value. The kinetic friction is less than Fms. That one I think in yesterday's class only. The last point what I drew in the graph. First we got up to F is equal to Fms like this. Later we got a constant value like this. Is it correct, Nana? Yesterday we wrote this, we drew this graph. Am I right? Yes, yes. So yesterday only we concluded. After coming into motion, the friction, whatever you are getting, is less than the maximum value of static friction. Okay, that one practically yesterday we observed in the graph. Theoretically also I am saying the same. Fk is less than Fms. Okay, this is the kinetic friction, and here related to kinetic friction, how the easy questions will come, sir. Why? Because you only told, sir, compared to static friction, kinetic friction is easy. Yes, it is easy only, obviously. Why? Because there is no testing. Okay, just we have to check F is greater than Fms or not. Then directly we can use only one formula. Fk is equals to mu k into N. Okay, that we will discuss tomorrow, Nana. Tomorrow, Wednesday, no problem. Tomorrow we will discuss. Okay, so shall we stop the class? Shall I stop the class now? Okay, Nana. Then if you want the pages, you can take. Thank you, Nana. This is the first page. Second, third, and fourth. Okay, Nana. Bye, everyone.